Very good. Okay, so afternoon, everybody. So we're going to be looking at modeling system workflows, as I said, and we're talking about activity diagrams. Activity diagrams look like flowcharts. How many people are familiar with flowcharts? If you did CSEC IT or programming a long time ago, you'd have done flowcharting. But basically, or you'd see it even at work, even in the business sense, even if you never did computing before. We use flowcharts all over the place. And as we start doing them, we'll start looking at the examples. You'll see that you are probably more familiar with them than you realize. Really? All right, so you have a use case model that you probably would have completed last time, or maybe you haven't completed it yet, but the point is that you know what is a use case model now, right? Good, our use case diagram. And some of the use cases are a little more complex than others, and you might be able to communicate better with a client if you provide a diagram or a pictorial representation of the details in a particular use case. By the way, you like the new classroom? Yeah, looks good, right? Yeah. Right. So, activity diagrams allow us to specify how our system will accomplish its goals. Activity diagrams show high-level actions chained together to represent a process occurring in your system. So a couple of things I want to highlight. This is where we can talk about the how. Remember, we don't talk about that in the use case diagrams. At no point should I see any lines going from one use case to the next use case. And when you're explaining to telling me that it's because this is first and then afterwards this happens, and then you call this one and you call that one. And yeah, that happens sometimes when people explaining, and I'm like, no, that's not a part of what we show in the use case diagrams. What we use our activity diagrams to show us that. The other thing is that we're talking about high-level actions. In use case diagrams, we don't usually try, in activity diagrams, we're not trying to drill down to the level of code or of objects or actual messages or, when I say messages, I mean like operations or calls, actual calls between objects in a system. You don't need to do that. The other thing is that we're talking about actions, and that's because activities are made up of actions. As you go along, the term activity is talking about all the steps required to complete a use case, and the steps inside are considered actions. So we're going to look at our use case that we had, our use case, create a new blog account. That's an example. Come on, why isn't this moving? Slow. All right, so this is an example. So I'm going to give you a couple of minutes. This thing is not cooperating. I'm going to give you a couple of minutes to look at it. And then we're going to talk about it. Not even a couple of minutes, 1 minute. We're just going to look at it and we'll talk about the different parts. All right, so you can see that an activity diagram is made up of a series of actions chained together, as we said. We have different kinds of nodes or different kinds of elements that we can have in the activity diagram. The first one you're seeing there is called an initial node. So it's a black circle, a circle that's completely filled in, right? That's called an initial node. All your activities start with an initial node. There are some exceptions that you'll see later in the presentation. The next thing you see is an arrow. That arrow is called an edge or an activity flow. Now, one of the things that you want to bear in mind is that these lines do not represent the transmission of data or objects or anything. What do you think these arrows, these edges here represent? Like this, for instance, what is that representing? The next step. It's just a matter of the flow of actions. It's just telling you what's next. So don't think that it means that data is being transmitted. There's a way that you can modify it so that you can indicate data being transmitted, and I'll point that out to you in a little while. So our first thing we know is happening in this activity is the first action is ask system to create new blog accounts. Now, you notice that we're not talking about who is asking. We don't know who it is that did the asking. There's a way to modify the diagram, which you'll see later on, that will allow you to specify who. That will allow you to specify who is doing it. But for now, we know that we're asking the system to create new blog account. And as I said, that's an action. This over here is just a note. Select account type is the next thing that happens. The next thing is we enter the author's details. The next thing is that we verify the author's details. And then what's this? What's that?
A decision. You do one thing or the other.
Right. It's a decision diamond. And in flowcharts, you have something like this as well, but usually you put a question inside of it. You can do that in activity diagrams as well, but usually we don't put the details of the decision inside. We just put a diamond just to say that there's a branching of the flow taking place now. On the branches though, on the two alternate flows, that's what they're called. Okay, my tape is off, is one of these. On the alternate flows, you specify the condition that must be true in order for the activity to flow in that direction. So here we're saying, in this direction, well, when you get to this point, we know that what's going to happen is that the application will be rejected if something is not authorized. The application, create new blog account will be, create new blog account will be the next step if the verify author's details is authorized, right? After creating a new blog account, we email blog account summary to author, and then we have, what is this called?
Decision.
This is a merge. So decision and merge. So you notice up here we had the decision, and down here we have merge. These, so there's this and this, right? So when you have a decision, so when you see these diamonds, you know which one is a decision, which is a merge by this. A merge usually has one arrow flowing into it, or one flow entering it, and two or more exiting. Because it means that you are on a the decision, yeah. Oh, I said the opposite. Sorry. The decision has one going into it, and then multiple branches coming out of it. Right. And then the merge has multiple flows going into it and one single one coming out. And they usually go together. So where you have a branching off or a decision, usually there's a merge later on. And then the last thing that you can see is this part here. This is called the activity final node. And what does that mean? It means that you're at the end of, that activity. There's another type of final node that you'll see later on. We'll talk about it later. Any questions about this?
You always label the initial node.
No, you don't label. This is just a teaching slide.
Yeah, the final node is the one with two circles.
Empty circle with a black circle inside of it. And the initial one is just a black circle. You don't put notes on things like that normally.
Okay.
Because they're part of the UML notation. So if somebody's reading it, they'll know what it means. It's just there for teaching purposes. But that is the symbol for putting notes on any UML diagram. Sometimes you do need notes. So for example, if you have an activity, like let's say reject application, let's say you want to clarify that whenever an application is rejected, it's recorded in a log. Then you'll put a note to explain that there. if you don't, if you don't have a step that you want to demonstrate here, clearly no, you might just put a note there. Okay, remember now that the action is one step in an activity. And the overall activity is normally linked to a particular use case. So the activity is a process being modeled, and the action is one step in that process. So lather, rinse, and dry are examples of actions. And wash car is the overall activity. Now, most times when you do an activity diagram, you don't necessarily need to put a frame around it, but you notice that this one has an activity frame. The activity frame is there because if you're going to reuse this activity later in another activity diagram, you put a frame around it and you label it so that you can use this activity within another activity later on. And you'll see what I mean later. But one of the things, the hallmarks of object-oriented design and object-oriented thinking is reuse. Right? Activity diagrams model an activity which is made up of various actions. We can use an activity frame. It's not necessary if you have only one activity on the diagram. You also get to include the activity name as well. So that's just explaining about the activity frame, which I mentioned earlier. So we're going to just talk about the different parts. We saw them in the diagram. I'm just going to go through points about the different elements that are part of an activity diagram quickly. So we spoke about decision and merges, and we said decision nodes are used when you want to execute a different sequence of actions depending on a condition. It's represented by diamond-shaped nodes. Remember we saw that? Usually there's one incoming edge and multiple outgoing edges. Each branched edge has a guard condition. The guard condition is what says whether this particular flow in the activity will take place or an alternate one. Right. So if not authorized is true, then you're going to go in the direction of not authorized. If authorized is true, then you go in the direction of authorized. Right? And that leads us also to the notion that it is important that when you use a decision, that all the alternate paths, now this example only had 2 alternate paths, but it could be more than 2. It can be 4 or 6 or 3, but every one of them must be mutually exclusive. It cannot be possible to do both of them. But 2 things can't be true. So you have to be careful how you create those guard conditions to ensure that there's no overlap or ambiguity between them so that only one can take place. Only one can be true at a time. And that, the next thing that we want to talk about is the merge nodes. The merge node is also a diamond. But the merge nodes are used to rejoin the multiple flows from a decision node. This marks the end of the conditional behavior started at the decision node. That makes sense to everybody based on the example we saw? Right. Mm-hmm. Right. From the same node. Once they're coming from the same node. Right. Right. They don't have to, but well, if you're talking about one decision point, then all the branches are going to come from that node. But it's possible that within the same activity, you could have other decisions, other decision points. So here's an example. I hope it's clear. Can everybody see this? Right, so word count equals 0. So we'll have the decision node and we'll have these 3 different branches. One says word count equals 0. The next says word count greater than 0 and word count less than 0. So we know as long as you're less than 1,000, sorry. So I tell you, when it gets down to this all the evening. So word count is greater than 0 and word count is less than 1,000. And then the other option is word count is greater than or equal to 1,000. So you don't have any overlaps there. They're all mutually exclusive. Either you're at the 0 mark, there's a particular activity that needs to be done, that is notify block entry can't be empty if the word count lies between 0 and 1,000, not inclusive. You see that? Because there's no equal. So if it is greater than 0, less than 1,000, then you go ahead and save the block entry. If it goes up to 1,000 or more, then it tells you that the block entry is too long, right? And then when you finish with all of that, it all comes back into the merge node, and then you can display status. Either way you want to display status, that's what it means. Either way, whichever one of those paths that we end up taking at the end of the day, we want to display status. But only one of those pathways can be taken. So it should be designed in such a way that no 2 or more branches from the same decision node will evaluate to true. Only one can be true at any given point. In other words, they must each be mutually exclusive of each other. So in one particular scenario, it may be that word count equals 0, in which case the system is going to notify block entry cannot be empty, and then it will display status. In another different scenario, word count might be greater than or equal to 1,000, in which case you'll notify block entry is too long and then display the status, and so on. But the two things, no two of them should be correct, should be true at the same time. And remember, each of these are called guard conditions. Okay. This was done in PowerPoint, and I'm opening it in Keynote, and something totally different is happening. All right, so look at these guard conditions and tell me so I have a note there that says bad. 2 guards may evaluate to true. So tell me what's the problem there. Rush order could be true whether the item is in stock or out of stock, right? So these are not mutually exclusive. Good. Okay. So how can we correct it? So we can modify it so that only one outgoing guard evaluates the true, as in these cases here. So these are 2 different options. One option is that we combine whether the item is in stock or not with whether it's a rush order or not, and that will give us 4 different branches from the same diamond. So 4 possible paths to go from the one decision point. Another option is to check for item in stock or item out of stock. And then based on whichever one is true, then we'll go ahead and check for rush order. But the point is that you will not end up with the situation of lack of mutual exclusivity. Make sense? So you have to think about those things and bear that in mind when you're doing activity diagrams. And although this is not directly linked to code, it tells the designer how they're to design the code and tells the developer how to code as well. So you can imagine the problems you'll have if it's possible that this doesn't get picked up early and you're going to design with it. And then there's fork and join. Now fork and join weren't in the diagram that you saw a while ago. But what's a fork? Anybody knows what's a fork? Yes, it's something you eat with.
It's the same that you showed now with the different the 3 arrows going to.
No.
It looks like.
Kind of, but not exactly. Do you remember what a fork is? Anybody? Okay, yeah. So forks get used a lot in computer science, actually. But if you did systems programming? Okay. Anyway, a fork allows you to say that there are some actions in this activity that you want to happen in parallel. So in other words, these things can happen during the same, they are not dependent on each other. You don't have a sequence that's required for their completion. And they're not as a result of a decision either. They're going to happen concurrently. All right, so let's just go through. So forks and joins are used in UML activity diagrams to illustrate parallel actions in an activity. Things that you want to indicate. So for instance, let's say, and remember that activity diagrams really are used to express things almost like at a business modeling level. You really just want to say at a very high level what the system should do, what the system should accomplish. You're not really talking about code, you're not talking about objects, you're not talking about anything too technical, not low level. So let us say that in our student registration system, students are required to add courses, complete a medical, and add courses, complete a medical, and also sign up for hall. And all three of those things must happen before they have to pay any tuition at all. None of them are dependent on each other. Like, you don't need to register for your courses before you. Can I tell you? I don't remember what I said.
Add courses, sign up for all,
and do medical, right? So, if you have a, oh Lord.
What you say? They're completely different. All of them need complete
right.
registration.
Say something as fast as I want, right? So supposing that was said. Let's see if there's anything missing from here. Okay, so fork and join are both indicated on the activity diagram with a thick bar. And the fork has one incoming flow and multiple outgoing flows, while the join has multiple incoming flows and a single outgoing flow. So in terms of how you use them, it looks similar. The symbol is different, but the way how you organize the actions look similar. But you have to bear in mind that when you see a fork, you're saying that these three things, there's no particular condition that makes you go in one way or the other. You're going, all three of these things must happen. One of the things that you have to bear in mind is that when you get to the fork, all three of these things must be complete before you go on to the elements that, when you get to the join, all three of the things or whatever number of things that were part of the fork, all three of those flows need to be complete before you move on to any actions that are in the sequence following the join. So let's look at following the join. So this first part here is called the fork.
The fork keys the join.
This, yes. So forking is what you use to say that, okay, prepare case and prepare motherboard are happening in, they're to happen in parallel. This is called a join. And the join, what I'm saying is that even if prepare case takes really long in comparison to prepare motherboard, both of them must complete before the actions that follow the join begin. Right. So let's look at an example here. So let us say that in order to put together this system unit, you need to prepare the case and prepare the motherboard, install the motherboard, install drivers, and so on. When you put your diagram together in this order, it means that prepare case and prepare motherboard can be done in parallel. They start at, and it might not necessarily mean that they start at exactly the same time or they end at exactly the same time. The main thing is that these two things do not have a precedence relationship. So you don't need to prepare the case and then prepare the motherboard. It means that they can happen concurrently. And it also implies that these two things must be finished. Once you do this, you're actually explicitly stating that these two actions must be complete prior to you starting to install the motherboard. So again, you need to think very carefully about what things you want to put, what actions you want to put in flows that come out of a fork. Because if you have an activity that is an extremely long activity, or an activity that is that's dependent on something, and there's a possibility that that other thing might not complete, then it might mean that you hold up the entire progress. So you have to think about, what's the best way to represent, and that might not be what you want to say, but that's what you will imply. So you have to think about where you should be using your decisions and merge, where you should be using your fork and join. Decision, as you said, as somebody said earlier on, fork and join doesn't have anything to do with conditions. It really just has to do with recognizing that these things can be done in parallel. And you want your developers to know that, and you want your business people, the business side, to recognize that this is how you have interpreted it. And then they can tell you if it's really so. Yeah? So even when parallel actions do not complete at the same time, that is, the parallel flows arrive at the join at different times, the flow following the join will not begin until all parallel flows arrive at the point of the join. That makes sense? That's the same thing we were just talking about. Moving on. Now, time events. Events are things that happen out. Yeah, I want to say outside the system. Yeah, let's call it that for now. So there are things that can happen. No, let's not approach it that way. The main thing I want to know is that in the same way that when you are drawing your use case diagram, you can indicate time, because there are certain things that are triggered by time. And so you put that in your use case diagram. I remember we said that you can use the hourglass symbol to represent time as an actor in your use case diagram. Remember that? Everybody remembers that? Or you can use the stick man and put a stereotype, that is, use a little game maze around the word time. And it will be understood that time is an actor. Something in your system is being triggered by time, a particular use case. Now, when you're drawing an activity diagram, sometimes moving from one action to the next, you realize that there is a particular amount of time that needs to elapse before you can transition to another action. So let's look at this example. We have our initial node here, and then we have ship order. So that's the first action. Next action here is send bill. However, you see this inside here. What that means is that after you ship an order, you must wait 3 days and then send the bill. Understand? But that's how you show that. Without having this time event here, what it would look like is ship order, then send bill. And under normal circumstances, that's fine. But whenever you know that that particular activity has time events associated with it, there's requirement for certain amount of time to elapse before you can move on to another action. This is how you show it. Use the time, use the hourglass, and then you specify what is the wait period or the delay that is required. Down here, we see the hourglass at the beginning of the activity. And this is a case that we use the hourglass when you put the hourglass here, you don't need an initial node. Remember I told you that you don't always need the initial node? Whenever there's an event that triggers the particular activity, you specify that event here. So what this is saying is that it is the elapsing of 1 second that starts this activity. This activity only has one action in it, and it is update the progress bar. So what it's saying in effect is every 1 second, you must update the progress bar. And usually this happens when you have like a repeated activity, an activity that just keeps happening over and over based off time. Now, once you have defined an activity, you have the option of using that activity almost like an action within another activity. Now remember, the actions are the steps in the activity, right? Right? So this is an action: prepare case, install motherboard, install drives. Those are actions, right? And this whole thing here is an activity. Now, look down here. This is an activity down here. The activity is prepare motherboard, and it's in a frame and it's labeled. The reason why it's in a frame and labeled is because it makes it, this is what you have to do when you want to reuse that activity somewhere else. So we have this initial node, install CPU, install memory, final node. And if you look, so it would just be another activity diagram. And this is why using an activity tool is good. So you don't think about it in terms of a document. You think about it as a real live structure that's a part of your model. It's just another part of your model. So if we were to switch over to
May I ask this?
You see?
If you're reusing, would it be the first instance where you work with probably somewhere close there, or is it maybe the end of the activity?
Right. So what I'm saying to you now is that you have to not think about it like a document. Think about it like a model. So let's go back to Star UML. And let's look in. Okay, let me open a different model. All right, so here are some use cases, right? Each of these use cases can have an activity diagram associated with it. So I'm going to open, let me move this all the way. I'm going to open, you can directly connect them to the use case, which is why you want to use a modding tool and not a document. So I'm trying to find a use case diagram. So here are some use cases. You can have one activity diagram associated with it. You can have multiple activity diagrams if you want to use an activity diagram to show different scenarios in the same use case. You can do that too. I'm trying to remember which ones have. Oh, view reports. All right, so here's an activity diagram here. So this is an activity diagram here. So it's like a separate object. So it's not like at the bottom or the top of anything. It's just at different entities. It's another part of your model. So if you wanted to reuse it in another activity diagram, so let us see.
So you can take that activity and put it in a different use case.
Yeah. So let me see.
You now have activity.
It would in a diagram. So if you were to convert everything into a document, it would just be a diagram in the document. So you'd have a list of activity diagrams, or it depends on how they organize it. They might have different use cases, and each use case has an activity diagram associated with it. And then each activity diagram would have a reference. Usually we try to put references on everything. Everything always has a number or a code or something on it. So when you're referencing it, it would either have the name of it would have like the name of the activity diagram. And so you'd be able to look for it in some other part in the document. But based on the table of contents or something, you'd be able to find where it is. So I hope that that's. The designer, they'd look at either. They'll probably start with the use case diagram. If that's the first time they're knowing about the system, they'd look at that. They might have a requirements document as well. So it depends on where they're at. Yeah, it depends on what aspect. So if they're, for example, if they're looking at if they're designing the architecture of the system, they might be interested in what are the main use cases. And those use cases, they might want to see the details for at that point in time. Some other use cases they might not care about. But when they're trying to, do design or development to complete a particular requirement. So let's say you're thinking about an agile development type of project, in an agile environment, like using Scrum or something. They're going to have a backlog, and that's what's going to tell them which use cases they look at and which scenarios they look at, which activity diagrams they look at what point. So it just, it's a type of a flexible kind of thing, varies. Okay. So what I was going to show you now is that right here, this little rake here, you see a little symbol there? It looks like a fork or a rake. Well, don't call it a fork because you don't want to think of a fork again. So the fact that we're talking about forks, you see a fork right here, it doesn't have anything to do with this fork right here. 1 year I was teaching and the student kept saying something about the fork, and I realized they actually thought that this was what I was talking about, that little thing there. But they call it a rake. Yeah, not a fork, because they call this a fork. So that symbol means that you're referring to an activity diagram elsewhere, to an activity. So this tells you that prepare motherboard is an activity that's defined somewhere else in this model or in this document. And there it is right there, prepare motherboard.
Oh, it's just before that word there.
Yeah, it's very small.
Oh, okay.
See it?
Okay, so that. Okay. So the rate tells you. Okay.
It tells you that that action is actually representing an activity. So if you
And the activity that it's referring to, the activity that is happening concurrently with that.
yes, it's an activity that should happen. So in other words, we already defined that this fork means that these two things are going to happen concurrently. So prepare case is just prepare case, but this one is telling us that this prepare motherboard means install CPU and install memory. That's what it's really telling you.
Okay, so it's just describing the activity of prepare motherboard.
Right. So it's just a way of making a diagram easier to read. But the fact that the rake is there tells you that the details of prepare motherboard is actually defined somewhere. Any questions?
The activity in general.
The actions. Yeah. So the actions are the steps and the activity is the overall process. Right. That's correct. That's correct. Right. Exactly. You only do that when you have either if you had done the other activity and then you realize that that same activity is required in another situation and you just go and reuse it, or if you have an action and you realize that that action needs more explanation, rather than, because we could always have, instead of putting prepare motherboard here, we could have put install CPU followed by install memory. But the idea is that sometimes it might just look like too much. It might make the work more crowded because you could have other forks. So prepare motherboard could have many steps in there with decisions and merges and forks and so on. So instead of using it to overcomplicate or to add additional complexity to this activity, instead we separate out that part into another activity. So it's easier to read. Right, exactly. It's easier to read. All right. Now, as I said before, these lines really only talk about what's next, right? These arrows here, they only talk about what's next. They're not telling anything about transmission of any data or any signal or any objects or anything like that. But there's a way. Only if you weren't in here. This here, this is a fork.
No, it's not fork. Just the vertical. Because I've seen that diagram.
Oh, swim lanes. Oh, we're gonna talk about it. Oh, I thought you meant something that was on the diagram right now. Yes, there's something called a swim lane or a partition, and that helps us to be able to say who it is that is responsible for a particular action, or where in an organization or in a system a particular action is taking place. So we're gonna get there.
The vertical line.
It's it's a different vertical line. Oh, the bubble above it.
You'll see like a fork in that. You have, say, 1, 2, 3, 4, 5.
Right.
And then you have action.
Going toward, it's probably forks you're talking about.
You have breaks in between, but then these actual lines will have like all of the different aspects of the system.
Yeah.
So
it's probably swim lanes. It's probably not the forks.
Yeah, I get what you're saying.
These are forks though. This is a fork and this is called a join, right? But later on, you're going to see something that looks kind of like this, but they're called swim lanes or partitions, and you use them to indicate that the particular activity belongs to a particular part of the organization or a particular part of the system. So maybe that is what you're talking about, but we're going to get to that. All right. I'm going to go straight to the example here. Right. The idea here is that sometimes you want to not just document actions, but you want to indicate that from one action to the next that you're actually transmitting some object. The object could even be a piece of paper, but you want to indicate that that is something that happens. So if, for example, you receive an order request and you need to take that order, you need to take an order and so you receive order request and then you approve payment, but you want to indicate that there's an order, an actual order object that goes from that is available after the receive order request action, and it is required by the approve payment action. So in other words, it's like something that needs to be transferred at the end of one step to the start of another step. And we can use an object node to show that. So it's just a square. Sorry, not a square, rectangle. And notice that the approved payment has a rate there. So it means that there's somewhere else where you have the details on that. And then we submit our order. Another notation, so one notation is by using the rectangle that you see there, this rectangle. Another notation is to use that and this. This one is called an output pin. The second one is called an input pin. The output pin represents an object that leaves or that becomes available at the end of a particular action. So like something you can transmit when you finish an action. And an input pin is something that's required, a literal object or a data object. It could be data. It can be an object. Yeah, it can be a data object in the system, or it could be a physical object like a paper or an order sheet or whatever that is required as input into an action. So these are two ways of showing it, and you can just specify the name of the object. Oops. The name of the object with a label right there. So this is the order. So these two diagrams are showing exactly the same thing, are saying exactly the same thing. Any questions? No. All right, let's move on. Another thing that we want to be able to do is to talk about different parts of an object. So you did not do object-oriented programming. Some of you did the object-oriented programming, but that's okay. You will recall, all right, when you refer to an object, if an object has different parts inside of it, you can use a dot operator in most programming languages to refer to the specific parts of the object. So for instance, on an order, you're going to have, for example, the names of the items, the quantities of each item, and the cost of the item, and so on. So if it is that they receive order requests, at the end of receiving an order request, you have an order object, and you can send that order object onto another action, right? Everybody following me so far? Supposing that the next action, like approve payment, really only needs the costs. Then you can show a transformation. Notice this note here. Transformation. And you can say order dot cost. And it means that only the cost part is being transmitted to the approved payment action. Because that's what approved payment needs. It only needs the cost. Of course, you could send the entire order, but it really only needs the cost. Right, you could do other transformations if you wanted. No, it's primary if you have attributes in that object. Yeah. Yeah. So it's things that you can get from the particular object. Yeah. Things that you can get from the object. If you want the percentage, then probably approved payment might want to find out the percentage, then it can work it out. Or you can, if you design your order so that's a part of it, then that's fine. Yeah, it's really right. It's the part of it that you want. And remember, this is not necessarily an object in the truest sense of the word. So it's not necessarily an object like a C++ object or a Java object. It could mean an order sheet. It could mean a paper that you call an order. Because remember, activity diagrams are really showing kind of high level, business level kind of processes. All right. The other thing is that we can talk about the state of the objects that are being transmitted. So you don't always have to show all these things or use all the tools that I'm showing you. But there are some times when you need to show certain things, and these are, so that's what you're getting the tools for. So let's look at this one. We receive an order request, and we are transmitting, we have an order as an output from that action, right? You can indicate that this order is actually pending. And after the approval process, then the order is approved. And then you can submit the order. And these are the two, right here and right here. These are either data or some physical entity, but those are the two objects. And we're only saying that they're in different states now. Another thing is that, remember earlier on we spoke about the fact that you can frame an activity, right? This is the frame. This will, oh, wrong thing. This is the frame right here. Sorry, this is the frame right here, right? Remember we saw it earlier on? I will frame the activity if we know that primarily it's important when you want to reuse the activity. Because when you frame it, it's just a syntax for saying that this is a complete activity and this is how you label it. So you can put the name, when you frame it, you can put the name in there. So approved payment. Remember we saw that activity being called right here. So it's the same activity. No. Right, okay. So what I wanted to point out to you, I understand when you're asking, I'm going to come to that shortly. What I wanted to point out is, do you realize that approved payment is an activity that receives an object, and it has an object as an input, and it also has an object as an output. How do you show that in the activity itself? How do you make it clear that the activity is like that? And you do that by doing this. So this here is the input, and this here is the output. Now your question is another question. The question is, shouldn't this have an activity, shouldn't it have an initial node and a final node? And I never even thought of that, whether or not.
No, but I understand why I wouldn't know.
Mm-hmm. I wouldn't even think of that. Mm-hmm. Well, that's not a complete thing because you wouldn't necessarily. Go ahead.
But I'm saying, but even with the rate, you notice that this is an activity that is happening. In the previous example, there was an initial node there, so
right. So in that context, it's already there's an initial node. But what he's asking is, if this can stand by itself, right, why don't we see?
Well, if we can use the one different action, that's
Right.
oh, you understand?
What was your comment, Patrick? What you just said?
No, I was saying if you can use it, the activities now on your friend,
Mm-hmm.
that they are transferring.
Right, reusable. Mm-hmm.
Different reusable.
Right.
Different actions.
Mm-hmm.
Yeah, I'm assuming that all action that you use.
So it may be, how I'm looking at it is that, because for example, when an event triggers an activity, you don't usually have an initial. When an event or like a external event triggers an activity, you don't usually have an initial node. And I'm thinking that this probably is a similar sort of thing, because what really happens is that this is really triggered by the arrival of this order. So I'm going to research this and think about it. But I just never thought of that before. I just always think of it that, okay, if you have an input and output node, that this is what it looks like. Mm-hmm.
That activity must always take on.
Yeah.
So it only can use actions
Exactly. So it's going to be used in conjunction with some other actions all the time, probably. So, but I'm going to look it up though, because I always just think of it like, oh, this it starts with an input and ends with an output. So I just don't think about the initial and final. But yeah, it's worth thinking about. Mm-hmm. Objects. Mm-hmm. Your voice is so quiet. I'm missing some of what you're saying. You just said something coincidentally.
Yeah, I'm saying activity that's
Right.
here.
Mm-hmm. Okay.
No, it just ends at some. No, it ends at.
No, not the entire activity.
I'm not sure why that just happened.
Yeah, so not the entire sorry, action.
Which
one? Receive order, receive order.
Right.
So here, receive order. Oh. Yes. So what I'm looking at order itself.
Right. Okay, so in the first case, so the first diagram and the second diagram here, they're saying the same thing. You understand that? Okay. And in this case, there's only, and as it relates to approve payment, okay, this is a different example from the last one. Well, there's an output of an order from receive order request. These are different activities. So the activity that we're just looking at a while ago, the pin in and the pin out, is actually the approved payment. No, what we were looking at earlier on, if I'm following what you're saying correctly, this here is the one that we were breaking down, that had the order going in and the order coming out. If I'm not mistaken, let's just go back and look.
Yeah, which is the same activity.
Yeah, this is it. Approved payment. So it's going back. Sorry, it's going back. It's just slow.
So this is the same activity.
No, this is a different activity. This is
the same activity. He said this
No, this is just kind of art.
This approved payment.
Activity.
Yeah, this art. Hold on, Patrick. This activity, approved payment. Look at the name, approved payment. Remember, approved payment. The input to it to get it to start is an order, and at the end, it gives an order as well. So in between, so you get the order, it calculates the total, authorized credit card, updates order status, and then it returns and it gives an order at the end. So remember, it's approved payment. Let us look at this one, for instance, now. This has approved payment. This is it right here. This is what we were just looking at a while ago. But it's just that I went into it. Does that help? Does that answer your question? Okay, good. Mm-hmm. Go back again. All right. These. Mm-hmm. Right. Right. Yes. Right. Right. Yes. Yes, you're right. It doesn't show any outputting of any order here. Yeah, it's not showing that. Yeah, it doesn't show it at all. Yeah. Yeah, it's not showing anything like that. Not necessarily, because this is just a teaching slide. It's just a demonstration. So it's just showing different things that can happen, because not every action that takes something as an input must have something as an output. So it doesn't really, yeah. Mm-hmm. So this now is just showing that this thing right here and this thing right here, if you match it back to this diagram, if you were to map this directly back to the one that we just looked at a while ago, then one would expect to see, which I think is what she's talking about. One would expect to see an output pin right here. Yeah. Mm-hmm.
Why that? It seems like one is
where? This one?
No, the last one.
Oh, the last one, okay.
Yeah.
Oh, these lines look like it's a feed. Yeah, it's only a frame. It's just a frame, but I think what I want you to see is that when you have an activity that has the pin out and the pin in, if it has a rake, then this is basically, it's just a way of showing that this is how you show the breakdown of an activity into its constituent actions while not losing the fact that there's a data in and a data out. It's just a input pin and an output pin. Just a way of showing it in the breakdown as well. Mm-hmm. No, they can be different actually. Yeah, you're right. Can be different. So it's possible that the order is an input, but an invoice is the output, or a receipt is the output, or something. It just depends on the business process you're representing. All right, sending and receiving signals now. In activity diagrams, signals represent interactions with external participants. Signals are messages that can be sent or received. And I'm going to skip this for now. And let's look at the examples. I think this is a better way for us to address than all that text. This represents, well, it says a send signal node. What it represents, so whenever you see that particular shape, the flat back, the back is flat, you see, like that. And then out here you have the pointed section. It means that you're sending a message from your system to some external party. It could be another system, an organization outside of the scope of this system itself, but something else that is sending a message to a request or something. When you see this shape, that is that, what you call it now, that open angle back, yeah? Consider it to be an opening to receive something. This is what you use when you want to indicate that there's a signal from outside coming into your system. Is not in the, no, your diagram doesn't need to show. You can put a note that explains what it is. Yeah, exactly. So for example, send request for credit card approval. That's obviously not in your system because you're not doing a credit card system. You're doing maybe some e-commerce system. But it needs that from, so there's a third party that provides that. And you need to get a signal back, like the credit card approval. So that comes from outside. So the two symbols for indicating interaction with external systems: send signal node, receive signal node. Right? And you have to remember, do not use them for messages inside of your system. It's outside, it's external. And then you can update status order. Again, remember I said that sometimes you don't use an initial node if, for example, a time event is at the beginning of the activity. Again, if there's an external, if there's a signal that is expected from outside, again, that is what triggers the activity. So you don't need to show. You can put it there, but by practice, we don't put an initial node there. So receive order, process order, ship order. Sometimes there are no incoming flows on a receive signal edge. This means the activity is initiated by the signal. The signal launches the activity. So you don't bother to put the initial node there. So the fact that that's there and nothing else is before it, it just means that that's what starts it. So we went through that already, but those are there when you're going through the slides. The notes are there for you. If you look at this section right here though, wait for signal from external entity. So when you put that in your diagram, it means that you're saying that after whatever action is before that, you're saying that after that action, your system or your business process doesn't do anything else until it gets a signal. So you're actually putting into your activity diagram or into your business model, you're saying that at this point, we're waiting for something. And the thing that comes afterwards is whatever it is that you want to do after you have gotten a response. Right? And you can imagine that there could be different kinds of responses, for instance. And if there are different kinds of responses, you might have a decision diamond afterwards that says, well, if the response is X, go this way. If it is Y, do that. If it's Z, do something else. Yeah? So these examples are pretty simplified because we just want to get the points across. But next week, you'll get a chance to do something much more interesting, right? We can use these to highlight the various participants in an activity. That's partitions or swim lanes. And I suspect that maybe that is what you're talking about. The other thing that sounds like what you're mentioning, what's the name again? Shanika. There's something else that sounds like what you're mentioning. It kind of reminded me of, it sounded like you might be talking about sequence diagrams. Right. So you're going to see something now that looks like a sequence diagram. It's not a sequence diagram. The lines that you're talking about in the sequence diagram means something totally unrelated to the lines you saw a while ago, the fork. So the fork has to do with indicating that certain flows in the process occur in parallel. It's just totally different, totally unrelated. It just looks kind of similar. So here's an example that we're going to modify, we're going to look at an activity diagram where we want to highlight who does what. And before I do that, let me go back a little bit. I'm going to go right back to where we started. And I'm sure there's an easier way to do this. All right, this one. Remember when we started, we said the first action is ask system to create new blog account. Select account type, enter, who's doing that? The activity diagram doesn't tell us who does it, right? But we know from our notes when we were doing the requirements that it's the administrator who has to do this. Now, supposing you wanted to make sure that that was clear on the activity diagram, who does what? Supposing that the administrator did certain things and then what is the name of the thing again? The authentication database did something else and so on. You might want to be able to indicate who does what, right? So that's where swim lanes and partitions come in. It's hard to believe that I have to move this slowly. This has a menu, you know, that will take me to where I want to go. But you see, because the Zoom is running, I've lost access to some of the features. All right, here we go. When Zoom is running, you don't have access, especially if you're recording and if you're sharing your screen. In order to record a desktop, I have to share my screen. I lose access to a lot of my features in the applications. All right. Sorry, that's not what I want to show. This is not what I want. See how slow it is? Not going down. All right, a technical support process requires different levels of support, including first level support, advanced support, and product engineering. All right, so there are three different parts of the organization that participate, three different parts of the organization that are involved in these different actions in the activity. So we can say, first of all, at the beginning, we log a complaint. When a complaint is logged, then we check to see if it's a known problem. If it's a known problem, then we can inform the customer of the fix. And then we close the call, right? I'm not seeing anything on this screen. And I do not know. Just a second. It will help if I have the screen up. Okay, so now if it wasn't a known problem, then we need to investigate the problem. But the people who the first level support only deal with known problems. Now, when it's an unknown problem, then we need some advanced help. So we'll go over to the advanced support section of the. So it's just like in a regular. So you realize it's a business process. It's not a programming issue. If you call Digicel and you say to them that my phone not working, and they say turn it on and turn it off, right? Turn it on and turn it off, and you turn it on and turn it off. Is it working? No, no. And they say open the back and take out the battery and put it back in, and it's still not working. It's still not working now. Wait, no, it's still not working, right? And then they say, okay, we have to log this and send it over to our technical staff. And so that's the advanced support. But the point is that you can use this not just for a system that you're developing, but if you just want to document, this is how a particular thing happens. And the idea here is that we're showing, so this one is really showing a business process, but this could even be different parts of a system. So if you're designing a system and you say, okay, the system has a UI, and it has a transaction manager, it has a registration manager, and it has a payment service or something like that. You can actually design the activity diagram so that the parts of the activity that have to do with a particular aspect of your system, you can illustrate that very clearly, while the other parts are in other sections and so on. And these are called swim lanes. They use swim lanes to help to indicate that. Right. So if it is not a known problem, we investigate the problem, and that happens in advanced support. If there's a workaround that exists, then we inform our customer of the workaround, and then we can close off the call. But if there's no workaround, then we go to product engineering because something is very serious here. And they investigate the severity, and they determine whether it's urgent or not. If it's urgent, then they add it to the request change database for critical patch, and then they inform the customer of the status and they close the call. If it is not urgent, then they add to a change request database for the next release. And then, of course, that goes to the customer as well. That info, that update goes to the customer as well. This one here, add to change requests database for next release. So it means that if it is urgent, the current release that they're working on, they're going to make that change for this present release. Right, so it's either it's urgent or not. Oh, it's just a matter of saying, you know, like it's just merging. So it's like if we say, yeah, so if we say, you know, if it's raining, we're going to carry the umbrella and we're going to carry our umbrella downstairs to the car. If it's not raining, we're not going to carry the umbrella. But if it's cold, if it's raining, we're going to carry the umbrella down to the car. If it's not raining, we leave the umbrella downstairs. But at the end of the day, we're going down to the car. And then after we go down to the car, we're doing the same, we're going to drive away. The point is that whether it was urgent and you had to add the change to the critical, add the change request to the database or critical path, or it was not urgent and you had to add the change request to the database for the next release, at the end of any of those options, you're going to inform the customer of the status. And then you'll notice that all three of these pathways, the initial pathways here, they all come right back to this final decision, this final merge here. So that's really, it's kind of very logical. When you make a decision, when you're at a point in a sequence of steps, you get to a particular point and you make a decision to go one way or the other. At the end of the day, you use the merge to show that independent of which part you take, there's a particular point where you merge. I don't know how else to describe it to you. It just means that any one of those parts will finally lead to a certain sequence of events afterwards, right? Right? So that's what it means. So that's how you know when you're looking at a diamond that's a decision or a diamond that's a merge. If it's a diamond that's a merge, you'll see different parts coming into it. If it's a diamond that's a decision, you'll see different parts going out of it. All right, so here's another way of showing.
So the lines were
these are not forks, these are swim lanes.
No, swim lanes.
Yeah. Or partitions, yeah. And they're just used to separate the different like stakeholders or actors that are a part of the activity.
They must always be solid lines.
Yeah. The dotted lines that you're thinking of, which is very, very often, are sequence diagrams. And we'll do that in a couple of weeks.
If the lines are
right.
We can still indicate that we have from one based on the lines. Would the other lines still indicate you're going from one level to the next?
No. These lines are used to separate participants in the activity, right? So this is saying everything here is first level support, this is advanced support, this is product engineering. 3 different participants in the activity. And the trouble with taking this approach is that you have to now make sure that even if it's a complicated activity, you have to try to squish things into the right places, which can be confusing. So the other way of dealing with it is, I've been sitting on too long, I feel so stiff, jeez. All right, so the other way of looking at it of approaching it is this. So if you notice, there is a little bracket up here, and here, and here, and here, and here. And it's telling you who's doing what. And that way, even if you didn't get the diagram exactly lined up, you can still say who is what. Because you probably will not be able to get it lined up that way. It takes more time to think it through to make sure that everything lines up. But in the absence of getting that done, all you need to do is just specify who is doing what. Right? And you don't want to make your activities too fine-grained, because, in other words, you don't want to try to record every single detail in an activity. You don't want to have 100. You don't have 100 actions inside of your activity, right?
But isn't there are lines between?
Yes, it is. It is difficult to figure out. It's difficult sometimes to figure out the level of granularity. But the best way to think about it is remember that it's a business process. You just want to communicate enough information, just like how you did the narrative for the use case is a similar granularity. You just want to say that, well, this needs to happen, followed by this, followed by that.
In my head, there are steps to be followed. So if I want to deconstruct this pencil, exactly. Step 1, take off the top.
Right.
Step 2, remove this part, right?
Right.
Step 3, remove this, and so on and so forth. But if it is that Patrick and Sam are going to have to come into the activity for the deconstructing because there are mechanical parts that I wouldn't know how to do. And Sam is responsible for half of it, and Patrick is responsible for the other half. But I then have to detail what Sam has to do.
Not necessarily. You have to ask yourself what's the objective of the activity diagram that you're doing. You have to ask who's the stakeholder that you mean to be reading, who you need to understand this. If you put in there that, well, Sam is going to get his micrometer screw gauge and measure the diameter of the lead and so on, is that going to help the process of deconstructing the pencil?
It could, depending on how pencil is.
Right. So right. Right. So it depends. It all depends on who are your clients and how much level of detail you're trying to convey to them. Who is your stakeholder that this diagram is meant for? And sometimes you can have it in a high level, and you have to remember too that this is not something that you're going to code from. There's somebody else called a designer. This is like kind of a part of, in a sense, this is part of requirements engineering. Yeah, if you think about it in a very traditional sense, you're going to have a requirements engineer who writes requirements. This is like requirements modeling. You're going to have somebody like, you're going to have somebody like a designer who is going to say, okay, now these are the structures that the software needs to have. You might even have a software architect that gives a high view design and says these are the components and this is how they'll be connected. Then you have a designer who will come in and say, okay, for this component, these are the classes and this is how the classes will interact with each other. These are the methods, these are the operations. And then these are the sequence diagrams that tell you how the objects are going to talk to each other to carry out a particular scenario. And then you're going to have a programmer now who takes that and fills in all the details in code. So this is not really necessarily, this may not ever be seen by, for example, a programmer. Because somebody else, a designer, will get this before. But it depends on what type of environment you're in. If you're in an agile environment, this might be what the programmer will get. Maybe. In Jamaica, sometimes I don't think that people really do too much of the business modeling, really. Sometimes I think people try to avoid that, except for the big companies, like the serious companies who know that they can't afford to lose money. They want to have properly documented systems before they start coding. And they use more of a waterfall type of approach. But when you have small businesses where everybody's together and we can talk to each other, I can say, what do you mean by so and so? And you say, oh, is this you want to see? Then I'll put it, and that's more of an agile environment. Yeah. Right. And even though they are using an agile approach, it doesn't mean that they will not do detailed documentation either. Some people tend to think that agile means you don't document. It means you just get up one day and start to program, which is a recipe for disaster. But that's what people tend to think, and that's not really true. A lot of young developers believe that that's the approach. But even if you don't do detailed documentation, you need some amount of documentation. That's where modeling can be very useful because it requires less in terms of writing, and big documents. But you can say a lot with a diagram. So as I said, in an agile environment, this might be what the programmer actually sees. It might be just that they have a requirements model and they might have an architectural design. They might not get a detailed design, but that's where but they have something that they start with. And the reason why it is okay for them to do that is because they develop little by little. So if it is that they misunderstood something or the client never brought across their point very clearly, they can always go back and fix it. And over time, they build up sprint velocity because they are picking up and understanding what is the overall picture. Yeah. So that is the difference between using an agile approach and using the traditional design all and build big one time, right? What else do we have to talk about? So in both cases, we'll convey information about who has responsibility for each action. Note that activity diagrams show activities and their actions at a high level, and I can't emphasize this anymore. This is what I was just explaining. So it's a high level, and so an action need not coincide with a specific message or a specific object. It also means that participants identified may be persons, departments, or software components. So it's not really about trying to come up with a design for the code. It's really about understanding the domain, either the existing domain or the domain within which the software is supposed to work. How, from a business perspective, is this supposed to impact upon the flow of activities? But sometimes it might be that you're talking about components in your system. Another thing is that you can use connectors, just like in flowcharts. You can use connectors to make your diagrams easier to read. And sometimes the diagrams can be big. So let us say that you had 6 steps, but the paper is too small. You can do 1, 2, 3, and then put a connection and label it. And then you start the next part with a connection with the same name. So N as the initial node here means that, well, it's not really an initial node, but if it starts at N, it means that there is a connection to some other part of the diagram somewhere. So you just have to look for N. So that's called a connector. Another thing is that there are 2 different kinds of final nodes. There's a activity final node, which is the one that we have seen several times today. That's this one is the activity final. And this one here is a flow final. And a flow final this is not a good example to show it. But if, for instance, a common place where you'll see it is if you have a decision. This one goes to this action here. This one goes to this action. This one goes to this action. But this action can end there, whereas these continue with other actions, and then they merge together. And go to the final. The idea there, this is a merge. So it doesn't continue. So this one doesn't continue. Even this, let's not even put a right. Supposing I wanted to, it merges here, and then we continue to do some other actions here. And then we finish there, right? The idea is that this particular path, if you go on this particular path, you don't have anywhere else going. So it's saying that this particular one here, this flow here is final. You don't want it to merge with the rest of them. And sometimes how we show it, is that you just draw a long line and carry it down here or carry it down to here. Sometimes you can do that, just draw a long line like that. But this is kind of more accurate because it says that after this happens, there's nothing else that's going to happen in relation to this flow. But if it is that all of these go together and you want to merge them and then continue, then you have activity final and flow final. One of them says that the activity has come to an end. One says that that particular flow has come to an end. So when you want to highlight that particular flow, you know what a flow is? A flow is one of the pathways that the activity could go on. So in this case, there's a flow that comes to an end. separate and apart from the activity coming to an end. So you can show it like that. Yeah. What else I want to? Right, and that's it for activity diagrams. So the next time we'll meet will be next week, Monday. We'll meet next week, Wednesday's a holiday. It's so unfortunate because I was so looking forward to us getting together on Wednesday. It's so unfortunate it's a holiday, you know, because I know we are diligent people and we like to get together and work hard, you know. If you guys are like me, we just want to get together and just work hard and just do lots of work and be productive. But you know, it's quite a misfortune. It's quite a misfortune that there's a holiday which will impede, it will you know, infringe upon our desire to be productive. That being the case, we will not meet again until on Monday. When we meet on Monday, we're going to start class diagrams and object diagrams. What I want you to do in the meantime, because we're not going to get together on Wednesday, continue working on that use case diagram, and then I want you to add some activity diagrams. Try and do even 1 or 2 activity diagrams linked directly to your use cases. All right? Yes, I think it's going to be fun, yeah. Okay, thank you all.
You're good, you're the only one here?
You're so